Hi guys, I'm Rohit Singham. My registration number is 18BEC0067. This is the digital assignment 2 of the subject of the course Computer Organization and Architecture. This is the course code. I'm doing this course under the faculty Dhanbal sir. This digital assignment which I'm going to explain is about computer is about the is about a resource paper. Uh, this is an analysis of a journal design and implementation of a control system using a AVR microcontroller. This is what I have selected my research paper. The research paper first question. Let's come to the first question. Explain how the selected paper related to COA syllabus or curriculum. The research paper which I have selected is the design and implementation of a control system using the AVR microcontroller. This is the information or the providers of the research paper. Uh, this error has come just now. I don't know why, what it happened. So these are the relations to this paper. Low power CMOS 8-bit microcontroller, AVR enhanced RAS RISC architecture instruction set, 4 timer counters, 2 of them are 8-bit and the others are 16-bit, 2 8-bit PWM channels and 6 PWM channels with programmable resolution from 1 to 8 bits. Most of the information to answer questions are in the journal paper itself. Other than that, I searched in various sites and I have used some online simulators and tools for drawing and sketching. So I compared the topic discussed in our course with the journal paper. So this is what how it gonna relate: timer, channel list, see, programmable watchdog timer on chip oscillator. Now let's coming to the second question. Draw the existing architecture discussed in the paper using Microsoft Visio and Adobe Photoshop software in EPS file format. I have gathered information of the existing architecture in my journal paper. So I searched about this architecture and took a screenshot and I have searched in various sites and I have picked up the accurate one. For EPS conversion, I have used an online EPS converter, but it was not that good. So I have did it this in this way. So we can clearly view the existing architecture of the paper with the proper graphics, flash, program memory, instruction register, instruction decoder, program counter, status and control, interrupt unit, display agent. These are all the units. Watchdog, timer, analog comparator, input output module 1, input output module 2, input output module and data stream. Now coming to the third question, draw the tabulated results and graphs using Microsoft Office suite in EPS file format. I found the results in my journal paper itself for drawing graphs and I have used the online site. Uh, but I have faced a little bit of problem while converting the diagrams into EPS format. So I have done this in this way: microchip, analog devices. These are all the processors in that paper, and these are all the compilers. These are the core marks for megahertz, FMS, and SWM. These are the technology. Next coming, and this is the maximum core marks, the achievable and normalized maximum core marks per square for each core configuration for the 6. Blue represents the FM, the red represents the SM, and the yellow represents the SWM. And these are all the technology. Next, coming to the draw the proposed architecture discussed in the paper using Microsoft Visual software in the EPS file format. A proposed architecture, a new architecture for less power consumption is given in the journal paper. I have used an online simulator for drawing, but it took a little bit of problem in gathering the information. So the thing is, the proposed architecture is HF RISC architecture. The architecture proposed here HF derives from the MPS ISA introduced in 6. More specifically, the HF risk ISA is a small subset of this thing. The following are the differences between the risk and the HF risk. Memory is accessed in a big Indian mode, no unaligned row stores. So these are all the differences. Even these are the differences between those two. I have clearly mentioned here. This is the diagram. You can clearly check here. This is another one of that. And coming to the next question. Draw the transistor level internal diagrams using multisim or CAD tools or EPS file in EPS file format. So the circuit is circuit with LM393. The internal diagrams are already produced in the journal paper itself, and I have used another sites for transistor level diagrams. It took a little bit of time, and it was a huge confusion while picking up them. Coming to the sixth question, compare the proposed architecture with the existing architecture in your reference books. So from previous questions and knowledge from textbook tabulated the difference between architectures. I have mentioned here. HF risk is a small 32-bit in order 3 stages. I have clearly fetched the information here, so I couldn't read this all now. This is the pipeline stages: fetch, decode, execute, and these are the comparisons between two, and I have differentiated as well. I have provided the information efficiently enough, so you can clearly check them. The question still continues. This is about the instruction set and also the differences and also the performance between both. This is all about the sixth question. The compiler is used to perform the conversion operation, means to convert a high level language statement into a code of its form, and the advantages and disadvantages. The sixth question continues up to here, and this is the end of the sixth question. Now coming to the seventh question, list the advantage of the proposed design over existing design solution. So these are the advantages. My my journal is new architecture. It has many advantages as mentioned from the existing architecture. So these are the FM version of HFS. So these 8 points are about the advantages over the existing design. So you can clearly check from point to point. This is the end of the seventh question. Now coming to the eighth question, let's list the merits and demerits of the proposed and existing techniques. So first I have mentioned about the existing techniques merits. So this is RISC architecture as a set of instructions, so high level language compilers can produce more efficient code. It allows freedom of using the space on microprocessors because of its simplicity. Many RISC processors use of the register for passing arguments. So these are all the points, and next coming to the demerits. These are the demerits. Mostly the performance of the RISC processor depends on the program or compiler, as the knowledge of the compiler plays a vital role. These are the demerits. Next about the proposed technique merits. So these are the 8 points I have mentioned here about the merits of the proposed technique. Short 3-stage pipeline to simplify code design and to reduce the chip area and energy consumption. No hazard of forward units. And these are the division units demerits. These are the demerits. These 4 points are about the demerits. I have collected this information from an online source, and also some of the advantages are listed in my journal paper itself. And this is the ninth question. It's about the list the application of proposed design. IoT applications typically require relatively high processing power combined to low energy consumption. In such applications, several architectural characteristics have to be evaluated. So these are the applications I have mentioned here. My thing has applications mostly in the IoT field, and I have collected this from the internet itself, and also my journal paper has provided some basic information regarding this. The ninth question continues. These are the another 2 points, and this is the end of the ninth question. Now this is the 10th question. Draw the flowchart or algorithm or transistor level circuit proposed in the design in EPS format. So this is the flowchart. These are mentioned in the journal itself. So I have chosen this one, and this is the journal paper. This is the abstract. Nowadays, the intelligent appliance is becoming an integral part of it. So this is the abstract basic instruction. This is the keywords used here, and this is the introduction. Control system. Next is the function introduction. So the subparts of introduction. These are all are hardware introduction. This is an IEEE produced journal paper. So this is the basic of this is the information from which I have collected about these all questions, and this is my journal paper which I have chosen. Software introduction, microcontroller. It's in a sorted format, so it's a bit confusing. So this is what I have given. This is the expansion. This is the circuit which I mentioned in the question 5. These all are the channels. These all are things, and the question continues up to here. And these are the references: Atmel, Atmega Corporation, Sharp Corporation, Philips Corporation, and the acknowledgement. This research was supported by the National High Technology Research and Development Program of China and the National Natural Science Foundation of China. This is the end of my DA2. Thank you.